For anyone trying to keep up with tech these days, especially AI, cybersecurity, cloud stuff, it feels like drinking from a fire hose, right? There's just so much out there, articles, research, endless online debates. It's overwhelming. So our mission today is to cut through all that noise. We've gathered insights from the big players like Gartner and McKinsey, mixed with practical takes from Presidio, Geeks for Geeks, in recent discussions. We want to distill it down, give you the core stuff you need. And today we're diving deep into something that's not just theory anymore. It's actively reshaping things right now, here in September 2025. We're talking about edge computing, specifically its massive role in supercharging AI-driven cybersecurity within cloud setups.
Yeah, this isn't just another buzzword. It feels like a really fundamental shift. We're here to give you that essential shortcut, get you right up to speed. Okay, so let's maybe take a step back for a second. What exactly is edge computing? And why is everyone talking about it so much right now, especially, as we're heading towards the end of 2025?
All right. Well, the basic idea, processing data locally, isn't brand new, but its comeback as edge computing in 2025 is definitely noteworthy. Essentially, it's about decentralizing. So instead of sending every bit of raw data off to some faraway cloud server for analysis, edge computing puts the processing power much closer to where the data is actually created. Think sensors on a factory floor, smart traffic camera, maybe a local server in a shop. That closeness, that proximity, it drastically cuts down latency, the travel time for data. And that's absolutely vital for anything needing real-time decisions. And look, this isn't just a minor technical tweak. It actually changes how organizations think about their whole cloud strategy. A lot of companies are finding that relying only on a central cloud creates bottlenecks, sometimes unexpected costs too. McKinsey actually found, get this, a quarter of organizations might regret their cloud choices by 2028. So edge computing steps in to fix that. It eases the pressure on the central cloud, gives you more local control, faster responses, and often it's just more cost-effective for certain tasks. It's about finding the right balance, really.
Yeah, you can totally see why. I mean, the scale is just mind-boggling when you think about it. We're looking at something like 75 billion IoT devices out there, all connected, constantly expanding the potential attack surface. That number is almost hard to grasp. How do you even start to manage and secure all of that efficiently from one central point? Local processing starts to sound less like a nice to have and more like a necessity.
That's exactly the challenge. And it's why Gartner's top tech trends for 2025 are so relevant here. They really point to edge computing as a key enabler for pushing AI out to the periphery. So this means putting sophisticated AI, like machine learning models, directly onto those devices or local networks, instead of constantly sending huge amounts of data back and forth, which, like you said, is basically impossible with 75 billion devices. AI can act right where the data happens. It makes the insights faster, more relevant, and yeah, way more efficient.
Okay, so moving from the what to the wow factor, I guess. The numbers behind this shift are pretty explosive, aren't they? They really show how fast edge is taking hold.
Oh, absolutely. And these projections, they're more than just big numbers. They signal a real economic shift. Edge computing is projected to handle something like 75% of all enterprise data by 2025. 75%. And when McKinsey talks about it driving $4.4 trillion in AI productivity, that's not just small improvements. Think about totally new ways of doing business, super personalized shopping, factories predicting maintenance needs on remote equipment, smart cities reacting instantly, things that just weren't practical before. And importantly, it directly tackles that growing cloud regret issue by giving businesses back some control and efficiency locally.
That 50% drop in response times you mentioned for distributed setups, I mean, that's huge for anyone who's ever stared at a screen waiting for something critical to happen. But can you give us a more concrete feel for that? Like, how does that speed actually play out in the real world?
Yeah, it's about making decisions in real time, not just faster. Verizon's 5G Edge platform is a great example. They're using it for detecting threats as they happen. Imagine a security breach trying to get into a network. If that data has to go all the way to a central cloud and back, even if it's just milliseconds, that's a tiny window for attackers. With Edge, the weird activity is spotted and blocked almost instantly right where it's trying to get in. It slams that window shut. Honestly, that speed can be the difference between a minor blip and a major disaster.
And that speed is obviously critical, especially when you hear stats like deepfakes are up nearly 600% and AI security incidents rose over 56%. Feels like a constant battle. But shifting so much processing to the edge, doesn't that also spread out the targets? Does it make the attack surface wider, maybe harder to defend in some ways? What are the new security wrinkles here?
That's a really important question. And actually, it highlights one of Edge AI's biggest strengths. Yes, the threat landscape is escalating and it demands faster defenses. That's exactly where Edge AI shines. The Stanford AI Index found that Edge AI can actually mitigate about 56% of adversarial attacks using localized machine learning. So instead of one big central target, you potentially have millions of smaller, smarter defense points. Each edge device running its own AI analyzes threats right there, learning and adapting without constant back and forth to the cloud. Plus, using large language models, LLMs, right on the device for inference. That cuts the amount of data needing transfer by around 80%. Huge! So, not only does it keep sensitive data more localized, which is better for security anyway, but it drastically shrinks the time data is potentially exposed traveling across networks. And this whole idea fits perfectly with modern zero trust security approaches, where you don't automatically trust anything inside or outside the network. Verify everything. By building these checks in right at the edge, organizations can cut the average cost of a breach by something like $1.76 million. So it's not just stopping attacks, it's building a tougher, more cost-effective defense system overall.
Okay, security makes sense. But what about the other big pressures? Efficiency, sustainability. These are huge deals now, especially with climate change and energy costs.
Yep. Yeah, absolutely non-negotiable for many. And the efficiency gains from Edge are pretty profound. We're seeing the cost of actually running AI models, the inference cost dropping by an incredible 280 times in some Edge scenarios. That makes advanced AI much more realistic and affordable for way more businesses. And crucially, Edge helps with energy use. AI globally is already consuming a massive amount of electricity, 536 terawatt hours, maybe 2% of the world's total. Edge can cut the load on those huge, power-hungry data centers by up to 35%. Just pause on that for a moment. Reducing data center loads by more than a third. That's a massive contribution to green IT goals and sustainability.
Wow. So it's clear this isn't just about optimizing one piece. It's about how everything works together. What does it actually look like when you strategically combine all these powerful elements, AI, ML, LLMs, cybersecurity, cloud, edge, into one coherent approach? Where does that synergy really spark?
Right. This is where it gets really interesting, where the pieces multiply each other's impact. Take real-time edge AI threat hunting, for instance. Picture machine learning models running directly on edge devices like a smart camera, an industrial sensor, maybe an IoT gateway. Platforms like AWS Greengrass help manage this. Now, these devices analyze data locally. If they spot something odd, maybe a brand new type of network attack or a weird access attempt, they can use on-device LLMs for quick, smart analysis. And then, bam! Enforce zero trust rules right there, instantly. It's not just faster reaction, it's proactive defense cutting off breaches before they even start.
So it's more autonomous, more intelligent, right at the potential point of attack.
Exactly. And this also helps massively with privacy concerns. Think about privacy-preserving federated learning. Edge makes decentralized LLM training possible. So AI models can learn from data across thousands of devices, like maybe individual phones or hospital sensors, without ever pulling all that sensitive data into one central place. This is huge, especially since privacy breaches make up 55% of incidents in hybrid cloud setups? Edge lets us build smarter AI that respects privacy by design. You get the benefit of collective intelligence without the risk of a giant data honeypot.
That feels like a massive win for sectors like healthcare or finance, where privacy is just absolutely critical.
Totally. And building on that, you see the rise of these scalable cloud edge hybrids. Technologies like containerization, especially using Kubernetes, are really key here. They package applications neatly, so they run consistently, whether it's on a tiny edge device or a massive cloud server. That consistency doesn't just smooth out data flow, cutting latency again by maybe another 50%, but it's also vital for integrating strong cybersecurity. When everything is neatly containerized and managed, it's much easier to spot and isolate threats. It even helps defend against things like complex disinformation campaigns targeting distributed systems. And just looping back quickly to sustainability, this whole integrated picture creates that sustainable power play we touched on. Optimizing processing at the edge, cutting data center load by that 35%, it directly supports green IT. Plus, making our digital infrastructure stronger at the edges makes it more resilient, which is increasingly important when you think about potential future threats like quantum computing. It's really a strategic play for today and tomorrow, hitting efficiency, security, and environmental goals all together.
Okay, this definitely sounds like a massive leap forward. So much potential for innovation. But, every big change brings challenges too. So thinking about you listening right now, what does the global landscape look like? What are the real opportunities you could grab onto? And what are the big risks we absolutely need to keep front of mind as we move through 2025 and look beyond?
Well, looking at the big picture, McKinsey's analysis basically paints edge computing as the essential foundation for what they call Industry 5.0. It's moving beyond just automation to truly intelligent, collaborative systems where humans and machines work seamlessly together. And looking even further out, imagine integrating this with next-gen tech like 6G or even emerging quantum technologies. Some people are talking about achieving unbreakable security. Edge is really that crucial groundwork making these advanced ideas feasible. It enables systems that are resilient, adaptive, and incredibly fast.
And for you, the listener, this translates into some pretty huge career possibilities. The analyses we looked at suggest that by 2030, we could see around 170 million new jobs, specifically in edge AI roles. That's tied to something like $15.7 trillion in value from upskilling. That's not just a number. It's a massive shift in the job market. So if you're looking to really lead in this space, getting skilled up in things like, say, PyTorch for running AI efficiently on edge devices, or maybe getting certified in Cisco's edge security, that could be absolutely critical for your career path. It's not just about defending systems. It's about being part of building this whole new world of distributed intelligence.
Absolutely. But while the opportunities are enormous, we have to be realistic about the risks too. They are high stakes. One major headache is interoperability, especially with so many companies using multi-cloud setups. Projections show multi-cloud use hitting 50% by 2029, making sure different clouds and countless edge devices can talk to each other smoothly, apply security rules consistently, and be managed together. That's incredibly complex. It takes really careful planning and smart architecture. And then there's the big one, supply chain attacks. This is a huge worry. Something like 61% of CEOs are concerned about it. As systems spread out to more physical locations, more third-party hardware and software at the edge, the potential attack surface just balloons. The supply chain becomes this really attractive weak link for sophisticated attackers. So this just hammers home the need for really strong governance frameworks, rules, and processes to manage security, ensure compliance, and handle risk across that entire edge-to-cloud system, right from manufacturing the device to processing the data. You need strategic oversight covering every single link.
Wow, what an incredible deep dive that was. It's absolutely clear edge computing isn't just some passing fad. It feels like a fundamental realignment, changing how we use tech, how we protect our data, and even creating whole new industries and career paths for you, whether you're learning or innovating in this space. It's about putting powerful AI and stronger cybersecurity right where it's needed most, boosting efficiency, and even helping with sustainability.
So as edge computing keeps pushing processing power and AI closer to where data is born, maybe the question to ponder is this. What stands out to you as the single most critical area for innovation? Is it making it even more secure, enhancing privacy, boosting efficiency further? Where do we need the next breakthrough to really unlock its full potential in the years ahead?
That's a fantastic question to mull over. Keep digging, keep asking questions, and definitely stay curious about how these fields are evolving. Thanks so much for joining us for this deep dive.